afternoon, everybody. For the record, I'm not missing class. I'm actually on sabbatical this year. Thank God. I love not going to committee meetings. I'm sorry. It's been a blessing. I'm really excited to be here. Thank you for having me. And I was going to say something, make sure I said you all, so you knew I was from Texas, but you can tell that from there. Well, I'm here to talk to you about a program that I developed called Focus. And I really like the title of our conference today because it starts with the word focus. So I thought that was very appropriate for me. I want to begin by telling you that I'm going to describe the Focus program, but I think we need to talk about some definitions before I move forward, because Terry came to Texas to one of our focus workshops, and we kept using learning support. And finally, she pulled me aside and she said, "What do you mean by learning support?" And I said, I figured out together after talking with her that we don't mean the same thing. So I'm going to refer to developmental math as developmental math. So that's what I think you call learning support, correct? And then I'm going to call credit-bearing class. I'm going to refer to three in particular: college algebra, contemporary math, which you've heard as quantitative literacy, that liberal arts math, things like that. And then we have a third course called college statistics and algebra, which is a different course that we developed at Texas State. So you'll see that language as well. We also use the term learning support, but we use that for the title of the lab piece that completes the Focus program. And I'll utilize the term program more than I will course. There are courses that compose the program, but the program contains more than just courses. So I just wanted to put that out there, especially since yesterday I was in a sustainability meeting, which I'm glad you asked that question, and my chair finally, and he's a new chair, it's his first year, so we'll give him a break. He said, you know, Selena, when you use these terms, they're not the same terms when I look them up in the dictionary. And I said, no, they're not. They're different. So it was really important for us to communicate. Okay, so here we go. Let me tell you a little bit about the journey. I told you about Focus already, but let me tell you how we got there, because I really thought that was important, what Nell said about before, during, and then after, and even looking at the future. So I've been interested in researching developmental mathematics for many, many years. And I don't know if Uri told you this earlier, and if you notice, I even hesitated saying Uri because I'm used to referring to him as Dr. Treisman, because I actually did my PhD, my undergrad and my PhD at the University of Texas. So, you know, it's hard to make that kind of shift. But in any event, I was... So I've always been interested. My dissertation was focusing on at-risk students. And when I went to Texas State as a new faculty member, I was promised the opportunity to continue to utilize developmental mathematics as my research emphasis. So what I did first and foremost was get in there and make a lot of pedagogical changes. So this started back in 1998. I had less gray hair. I had gray hair, but I colored it. I had less gray hair, no glasses, which I have glasses, less weight, less children, all those good things. And I adapted the model that I used in my dissertation to developmental mathematics. And basically, you'll see that as one of the instructional techniques. That continued for several years and continued to infuse these pedagogical practices, which I would concur that cooperative learning is definitely one of those. Then in about 2007, I received a phone call asking if I would co-chair the vertical team that wrote the college and career readiness standards in Texas. So I agreed to that. Well, I agreed. I was told. I said, okay, and I smiled. And that really helped me make a lot of the impact from a curricular level. So I started to think about curriculum moving away from a pure algebraic structure to something that was more broad, that included geometry, measurement, probability, statistics, and of course all the process standards. And even way back then, Uri doesn't probably remember, but as I would see him in conferences, he was already putting out the word about statistics and its importance. And I latched on to that, and I thought that is one thing we definitely need to do, and we need to continue to broaden things so that we can equip people with thinking skills and strategies and not limit them to geometry or algebra or even Euclidean geometry for that matter, that we should think about math in general. So in any event, that is when the focus program came to be. That summer, I thought it would be interesting to put developmental mathematics side by side with the credit-bearing class and see what happens. And this would be a convergence of all the pedagogical change that I had already created with my new curricular insights, and hence the birth of the focus program. And by the way, these slides sort of talk a little bit about the journey that we've had in mathematics education. You'll see that this, and I was also a high school teacher. I taught high school for a few years. So this was very much the case. This is the new math. Ready for the next one? No, don't show you anymore. Just close your eye. Back to the basics. Ross Perot, remember him? It's coming. Okay, great. That was a hit. So here we are in a new decade, right? And now we're talking about a lot more change, a lot more change. I'm glad you enjoyed that. Okay, so our agenda, I'll whip through this and just get to the focus model. So I like to think about the focus model, the focus program, as a three-legged stool, where the base of the stool is actually the credit-bearing course. And if you see the rim of the stool, you'll see all these best practices, research, evidence-based best practices. I have a degree in mathematics, but my PhD is in mathematics education. So really embrace all of those things that we're studying and researching, and like to see them in practice and should practice them. The three-legged stool. So what are the three legs? One of them is the developmental math piece. And at Texas State, for example, we have 2 developmental math classes. I'm not going to bore you with the numbers because it's irrelevant anyway. But in the focus program, we only have 1 developmental math course. And it's a compilation of the mathematics content that's necessary to provide the prerequisite knowledge for the credit-bearing class. So we don't even call it Math 100 or Math 1311 or anything like that. We call it developmental math. The second leg of the stool is the learning support. Remember, I warned you about that term. It's not the same. So the learning support is a model that we've constructed, which is a 1-hour-a-week lab where we actually follow a specific format. And I'll provide you with those details in just a minute. Also part of the learning support is a 2-hour requirement of tutoring, and it's tutoring from an approved source. It's not just, well, my best friend's mother used to teach 5th grade math, and she said she'd help me. No, that's not going to work. We need an approved source. We need a source that knows what we know and knows how to complement what we're doing in the classroom. So we limit our sources to our learning support, our Student Learning Assistance Center. We call it SLAC. It's probably not the best name, but it had nothing to do with that. Our tutoring lab, our math lab, We also have quite a few athletes, so the athletic tutoring is available, and then student support services has their own tutoring. So those are the, and the actual instructors of the program. Those are the only approved tutoring sources that we allow. Okay, then you see the other leg, which is the academic support services. And the academic support services are basically these wraparound services. We require them to have a mentor, to go to advising, to be knowledgeable of the counseling services that are available, to go to college going and success workshops that we put on once a month. So that's where I'm talking about it being a program. And what I like to allude to is this idea of a band. All these components are banded together to make this program. So what are some of the influences? When we did the development of the college and career readiness standards, we had a lot of consulting from David Conley, and I really gravitated to his definition when he talked about redefining college readiness. And I like this because this was one of the first times that I saw somebody actually talking about things being beyond content skills. So I really embraced that, and hence you see that third leg with the academic support services. So if you want to look that up, if you Google redefining college readiness, it'll be one of the first links that comes up. He also has a couple of books out, College Knowledge, but this particular one that I really like, it's on page 12. Okay, so here are the three pieces in a little more detail. We have the credit-bearing course, the developmental math, and the learning support. And here you can actually see where I was talking about the contextualized, for the format for the learning support. You'll see the contextualized real-world problems. We utilize a math science model called correlation. We investigate the links between numeracy and literacy. We infuse cultural relevance, and we take advantage of any technology to really elaborate and solidify conceptual understanding, the concepts that were investigated in the developmental math and the credit-bearing class. You'll see this hot topics. It looks cute and simple, but we actually talk a lot about, and we train our instructors to utilize adaptive expertise so that they can really look at what people don't understand. We can predict those kinds of things, and we can be ready to address that topic in a whole other way. So we have 3 bands. College Algebra Focus. Here's an example of the College Algebra Focus, so you can sort of see how these topics come together. So, for example, in row 2, you'll see operations with polynomial expressions and rules of exponents. That's what we talk about in developmental math, so that we're ready to receive and engage in information regarding polynomial functions. And in the learning support, we do an activity that talks about the Mayan numbers and using polynomial expressions to convert numbers to different bases. In college statistics and algebra. Now let me tell you a little bit about where this class came from. Well, we wanted to do something that had a pure statistics for all the reasons that you heard and will continue to hear. But the problem was that I'm at a 4-year university, and a lot of things are very departmental. So there are a lot of departments we're not going to have it. And the math department especially was already having problems with the fact that statistics was being taught in other departments, and I really think that that's not going to change. Everyone feels like they need a specific type of statistics. It'll be a significant change to try to pull back and put it all back in the math department. So we also had this thing called general education course requirements, and that is a pool of courses that everybody has to take from. And statistics was not one of the general education course requirements, even though the state of Texas has noted statistics as a sophomore level class, and it does satisfy it can be transferred. It wasn't acknowledged as part of the degree or program of study. So I decided that it would be a good idea to then think about a class that would get us halfway there. And it actually turned out to be pretty cool. Just now, it will be on the books starting the fall of 2013, but we've been running it under the College Algebra umbrella so that we could do the fine-tuning of the content and really see what kind of things we need to push and pull on. So that's another course that we have. And then our third band, which is the contemporary mathematics. So what's interesting about the contemporary mathematics is that we also tried this for a few years, doing 8 weeks in 8 weeks. So still keeping them as prerequisites, but just doing them accelerated. And we have data to support that that still is not as effective as utilizing the co-requisite model. Okay, so how did we actually construct the classes? Well, we utilize a backwards design. I mentioned a minute ago the academic course guide, which is the law of the state, right? What the course should look like. And then, of course, there's the law of the land, which is my math department. So I looked at, you'll see on the left-hand side, that's what our uniform syllabus looks like for college algebra at Texas State in the math department. And then on the right-hand side, you'll see the Texas Higher Education Coordinating Board description of their academic course guide. So we looked at these two things and we did a backwards design to determine what it is that we really want college algebra to look like and make sure everybody was happy. So in a nutshell, this is one of the brief outlines that shows what our college algebra class looks like. It's very functions-based, and we explored a lot of different kinds of things. It is very conceptual. The applications and all those other things come in the learning support. Okay, what about the developmental math? Well, for developmental math, we use a just-in-time approach. And you saw that in those examples briefly. So we take all of the objectives for college algebra, and then we map back. And we say, what do we need just at that point in time to make sure that we're doing well and that the students are ready to receive that knowledge. And so that's how we do that. And then I'm just going to sort of briefly go through some of these instructional techniques. I don't want to bore you too much, and it's a different kind of presentation. But just to give you an idea of all the different instructional techniques, that's the 4-phase algorithmic instructional technique that we utilize. We also utilize Kolb's model for experiential learning. Here's some examples. We borrowed from math learning disabilities. They have the concrete, representational, and abstract model. So we do a lot of that. And you'll see that. We utilize a lot of instructional tools. We use manipulatives. I mean, we're not afraid to bring out the algebra tiles, things like that. We use miras, dice, nets, and we go back and really construct things. We utilize a lot of technology. We utilize Fathom, Geometry Sketchpad. I mean, we just have whatever's conducive for that particular topic, that's what we do. And cooperative learning, we definitely use that. And some examples. And here's a little bit about the curriculum, because I know you're a Common Core state because you're not Texas. Texas does college and career readiness standards. So, but we have 10, and just so you'll have an idea, but I sort of spoke to this already, the numerical, algebraic, geometry, measurement, probability, and stats. And functions is a standalone standard. And then, of course, all the process standards. And we utilize this cultural relevant model. And it may seem like this is a lot of stuff, but we don't do all of it all the time. We just do what we need that's conducive for a specific topic or for a specific lesson. So we go, in this particular case, we go beyond what people normally think it means to be culturally relevant, and we don't necessarily use culturally responsiveness. That's a little more work for us, and it's a little harder to do with a specific, each group. So we rely more on culturally relevant ideas. Some of the topics that we do. And here's some of the other things, and I really want to spend a little bit of time on this. And this is one of the new things, well, I say new, but it's been a couple of years that I've been investigating what we mean in developmental mathematics about this idea of constructivism. So anybody who has anything, which is all of us, to do with teaching anybody anything, you've heard constructivism, right? You've heard constructivism, you may have even heard socio-constructivism. That's the latest thing. You may have even heard more detailed information like schema or zone of proximal development. So all these things about how people learn. But as I kept thinking about that, I kept thinking about how that's not true for this particular population of students. We're not just talking about building understanding, building concept. We're talking about having to get rid of the bad stuff, the stuff they learned wrong or memorized, or just what I like to call junk. Like, I freaked out the other day. I help some students at the local school, and one of them came back and said to me, I said, well, what'd you learn today? And she said, oh, I learned the butterfly method. Okay, butterfly method? What's that? Can you tell me? Because I haven't heard of it. And she said, well, you know, it's when you have a number at the top, a number at the bottom, equal to another number at the top and a number at the bottom, and you're trying to figure out what one of those numbers is, and so you do the butterfly method. And I said, oh my gosh, this is a problem. This is a problem. I could not believe it. I could not believe it. So, you know, there's no concept being built. Then we wonder why we have problems, right? And I wondered if the teacher even knew what that person was really doing. I mean, because calling it the butterfly method was far from being the truth. And we believe in telling the truth, telling the story. You might not be able to tell the whole story, but the part of the story that you tell better be true. So things like, you can't take the square root of a negative number. We don't say that. It may not make sense to take the square root of a negative number in the reals, but if it's a complex number system, it makes total sense. So we don't massage the mathematics to make it easier for us to have people memorize. That's not what this is about. And you'll see, even though, unfortunately, I didn't bring the slides that have a lot of our data, so, you know, I sort of should have gone before now, but anyway. But I will say this, we have phenomenal results, phenomenal results. We've been doing the focus program since 2008. We've had over hundreds of students in our sample size. And we have over 80% of our students make a D or better in the credit-bearing class. And we followed students, many of these students, and remember, these are students who hate math, who hate it, they detest it, they blame it for not being able to graduate from college. And we have those students now choosing to take a subsequent math class. And for those students who have chosen to take a subsequent math class, 68% have made a C or better. We have completion data, people going to moving forward and graduating from college. We have that data to support its effectiveness. We have data to support that they've done well on standardized exams, because people will say, right, I mean, that's a natural thing. Well, yeah, you're teaching the class, so you can give them any grade you want to give them. But we have them take the THEA, which is the standardized exam in Texas, not the most best aligned to capture these kinds of results, but it's a measure, it's a metric, and it's a credible one for that, in that respect. We have students take the LASSI, which is a Learning and Study Strategies Inventory, and we've had statistically significant results on all 10 scales of the LASSI. We have them take a math anxiety rating scale, the one that Swinney developed, and he's actually allowed us to put it online at a very reasonable rate, and statistically significant results in that. And here's the big one, and I know we already heard this a couple of times, but it's still nice to say. We now have over 15% of students that have gone through the focus program change their major or their minor to math. They hated it, they love it. They were afraid of it, they embrace it. That was an outcome I had never even expected, never. I saw a glimpse of it the first time we did it. I saw the turnaround, different people asking other questions, And now I see, oh my gosh, it's happening. Because now they finally understand it. So I want to show you, here's that other thing. Don't look too hard at the foil because it freaks me out even to say the word. So some of the other things that we do, I just want to show you this video clip really quick. Oh, well, I don't want to surpass the academic, but I think I've talked enough about this. So here's John Bailey. Oh my gosh, he has a story. But I will tell you that he's a very good success story, but quite honestly, we have quite a few. We have a lot. In fact, I could probably count on my hands how many we are not success stories. And those are people who opted out of the program early on. So that is the focus program. Do you want me to take a question? Yes, Terry.
Will you explain to everyone how a student enrolls in the focus program?
Yes. So we actually have an application, and the students, a lot of the students will tell you that they've heard about the program through an advisor or a friend that has been through the program. And so we have an application online. It's actually public access. You can go to Texas State University's website and look up, search for focus, and you'll see that there. And then the student, like some of the parts that we ask the students to include are references, and I actually call them sometimes so that they know that I call. And they also have to write a couple of statements on their willingness to work hard in the class and what are they going to do differently and their commitment, that kind of thing. And we review the applications, and not everyone gets accepted because we are limited in our capacity. So we review applications, and then we offer positions to individuals. Oh, yes. The written, they take written exams. The students take written exams. Is that what you're asking? What type of assessment? Mm-hmm. They take written assessment exams, and they're not all multiple choice. There's some true false. There's problem solving, problems that they answer. There's some, definitions. They have to be able to define things. They definitely need to know the definition of a function, things like that. And I also want to tell you that we're replicating the focus program across 7 sites in Texas. And those sites have had similar results as ours. Yeah, we do have, yes. So the question is about the assessment, and even across the state, we all take the same test, and we have an agreed upon rubric. So we all agree, we start the test development, so we write the test first, we put it out there for review and comment, and then all the other instructors say yes, no, or no, change this. We make multiple versions, and then we develop a rubric that we all agree on the grading scale and how to do partial credit. Yes?
I guess who is conducting the lab part and how it fits in?
Okay, that's a good question. So the question is about who's conducting the lab part, but I'd like to elaborate on who's doing each part. So there's an instructor of record for the credit-bearing class, and then there's the instructor for the developmental math, and it's not the same person. And any of you have seen other models that are not math, like, for example, what Peter Adams does. He's going to say that he thinks that person should be the same person. But I argue that it should not be the same person, that they should be different people to push and pull on the students and use that to your advantage to keep up the pacing. And then the learning support is actually taught by an undergraduate student that's a math major, or somebody that is interested or wanting to get certified to teach, or a graduate student. But we actually break into a lot of different groups, and the people, it gets a little complicated, but the people that are teaching the developmental math class, they actually sit in the credit-bearing class and help facilitate, and that's done in a larger group. So the first time we did it, for example, with the credit-bearing class, we had 50 people in our credit-bearing class. So there were 50 people, I was the instructor of record, I was doing my thing, and the developmental math instructors were in there being able to react to different questions and different kinds of issues that were happening in real time. And then the developmental math classes were broken up into smaller groups, so it wasn't the 50 that we had in the credit-bearing class, there were smaller groups. And that does lend itself to an issue regarding sustainability.